For millennia, yogic traditions have defined the human anatomy as an integrated energetic network. In this model, life force, known as prana, circulates through 72,000 subtle channels called nadis. Because early dissections and modern imaging found no physical tubes corresponding to these 72,000 channels, clinical medicine historically dismissed the concept as metaphysical abstraction. Recent advancements in neurophysiology, fluid dynamics, and quantum magnetometry now allow us to map these ancient heuristics directly to objective biological systems. By examining the exact biomechanical, biochemical, and electromagnetic pathways of the body, we can evaluate the physical reality behind these descriptions. These ancient anatomical models appear to function as highly perceptive, subjective maps of objective physiological phenomena. Consider nadi shodhana, or alternate nostril breathing. Ancient texts divide the respiratory pathways into two primary energetic channels, the cooling, lunar side, called Ida, and the warming, solar side, called Pingala. In modern anatomy, initiating a breath through the right nostril, the solar Pingala, directly stimulates the sympathetic nerve trunks running down the spine. This triggers a sympathomimetic response. The body releases adrenaline, which accelerates the heart rate and increases blood pressure, preparing the system for physical action. Conversely, shifting the airflow to the left nostril, the lunar Ida, activates the vagus nerve and the parasympathetic nervous system. This creates a sympatholytic effect. Heart rate slows down, blood pressure drops, and reaction times are reduced as the body enters a state of rest and digestion. This chart shows the heart rate variability low frequency to high frequency, or LF/HF ratio. The LF-HF ratio is a clinical metric used to evaluate the exact balance between sympathetic and parasympathetic nerve activity. Here, we see a control group's steady ratio compared to a sharp downward curve in an experimental group performing left nostril breathing, indicating a shift toward parasympathetic dominance. The data demonstrates that alternating nasal airflow acts as a direct mechanical override of the autonomic nervous system. The cooling and warming energies described in ancient texts serve as functional descriptions of the binary toggles of the human autonomic nervous system. Between Ida and Pingala lies the central energy channel, known esoterically as Sushumna. Anatomically, this maps directly to the spinal cord. The spinal cord is immersed in cerebrospinal fluid, or CSF, a dynamic signaling medium that transports nutrients and hormones throughout the central nervous system. Advanced respiratory practices often pair breath retention with targeted muscular contractions called bandhas. These locks create intense mechanical compression within the abdominal and pelvic cavities. When engaged at the base of the spine, near the sacrum, this compression acts as a physical hydraulic pump. It pushes the cerebrospinal fluid upwards along the neuroaxis against standard gravitational flow until it reaches the center of the brain, flooding into the third ventricle. The third ventricle is a narrow cavity situated precisely on the midline of the brain, surrounded immediately by the pineal and pituitary glands. The esoteric concept of a rising kundalini energy maps to this active hydraulic manipulation of cerebrospinal fluid pressure along the spine. In esoteric literature, this midline space is described as the crystal palace, or the cave of Brahma. As pressurized cerebrospinal fluid floods the third ventricle, it sweeps over microscopic antennae called cilia in a rhythmic mechanical wave. This mechanical stimulation of the cilia applies direct physical stress to the adjacent pineal gland. This mechanical stress is hypothesized to trigger the endogenous release of localized neurotransmitters, such as serotonin and potentially dimethyltryptamine, or DMT. While endogenous DMT production remains a subject of active research, the mechanical arousal of the pineal gland provides a plausible biological trigger. The presence of these compounds in the third ventricle corresponds with shifts in brainwave patterns, frequently inducing high-frequency gamma waves associated with expanded states of awareness. These findings suggest a potential neurochemical basis for yogic states, where a mechanical hydraulic trigger initiates a measurable change in brainwave activity and subjective perception. If bioenergetic signaling is a measurable physical process, how does it travel to areas outside the central nervous system? The connective tissue matrix, or fascia, acts as the physical structural substrate for a body-wide network. practices like yin yoga utilize 5 to 20-minute static holds to place sustained mechanical stress on joints and deep connective tissues. This stress activates the piezoelectric effect. The piezoelectric effect is the ability of certain solid materials, like bone and collagen, to accumulate an electrical charge in response to applied mechanical stress. By physically deforming the molecular crystalline lattice of the tissue, the body generates an electrical charge that operates independent of the nervous system. This sustained stress also triggers a secondary biochemical response. It stimulates the local production of hyaluronic acid, or HA. Hyaluronic acid is uniquely hydrophilic, meaning it readily attracts and binds up to 10 times its own weight in water. As these massive molecules coil together, they trap free water to form continuous, electrically insulated tube structures. The aqueous solution inside these tubes creates a highly conductive channel throughout the fascia. The piezoelectric charges generated by the stretching of the tissue travel efficiently through these newly formed water-bound pathways. This mechanism provides a biological framework for the ancient concept of prana. In this model, the movement of energy through the joints corresponds to the physical propagation of piezoelectric charges through water-bound hyaluronic acid channels. These localized phenomena, autonomic shifts, hydraulic cerebrospinal fluid pressure, and the piezoelectric charging of the fascia combine to create a systemic electrical output. According to the laws of electromagnetism, all internal electrical activity generates a corresponding external magnetic field. These biomagnetic fields are weak. The magnetic field of the human brain is measured in femtoteslas, while the heart's field is in picoteslas, billions of times weaker than Earth's magnetic field. To measure fields this faint requires specialized quantum technology known as superconducting quantum interference devices, or SQUIDs. A SQUID is a highly sensitive magnetometer used to measure extremely subtle magnetic fields. Because the fields are fragile, these measurements must take place inside heavily shielded metallic rooms to isolate the body's magnetic signal from ambient terrestrial and radio frequency noise. Under these sensors, the human energy field is a quantifiable electromagnetic footprint. This visual shows a spatiotemporal magnetic field map, or MFM, the primary visual output of a SQUID sensor array. This map overlays dynamic contour lines on a human heart that shift, expand, and pulse in perfect time with the cardiac cycle. Researchers use this beat-by-beat mapping to evaluate the structural and electrical integrity of the organ without physical contact. By analyzing the magnetic field's geometry, clinicians detect objective anomalies. Here, contour lines warp into an irregular, asymmetrical pattern, flagging an ischemic indicator. The sensors are sensitive enough that the subtle electrical changes associated with ischemic heart disease can be detected in these magnetic fields even when the subject is at rest. By manipulating the breath and physically stretching the connective tissue, the human body alters its electrical output enough to generate measurable, diagnostic quantum data. Understanding the physics of this subtle body bridges the gap between preventative lifestyle interventions and advanced clinical pathology. The integration of ancient biomechanics and modern biomagnetics suggests the body's energetic network is an intricate, quantifiable system of physics and fluid dynamics that we are only just beginning to master.